Okay, hi guys. Can you wait, let me see. Can you hear me? Can you guys hear and see me? If you can, please turn on your cameras and we can get started. Okay, thank you. So for today, we're going to be talking. Today is our 6th lesson, which is congratulations. We've gotten through half of the entire course for this season, and today we're going to be talking about counting principles, which is going to be a little bit more complicated a little bit more complex compared to the one that we learned before. But that's okay. We're going to get through it. So before we start, I'll talk about a little of the formulas and basic principles that we'll need to get through before we start the preview questions. So firstly is permutation and combination. So for permutation, it's pretty simple. So for example, if a question asks you something similar to, if there are like 3 people and how many ways they can be sorted to stand in the queue, then for that, then we're going to use something like that will be denoted as this or this. Since there are 3 people, then there's going to be 3 here and 3 on top. So that would just be the factorial, which is 3 times 2 times 1. But usually we don't go through something that's complicated. We can just use this factorial. And I'll go through that later during the multiplication principle concept. And secondly is combination formula, which is a little bit more important. Because let's say we have a problem that asks us, there are 7 marbles and we need to 7 different marbles, and the question asks us how many ways are there to pick 5 marbles from those 7. Then the combination method would basically, we would have 7 on the bottom and 5 on top with this C as a denotation. So basically this means that we need to choose 5 out of 7. And there are also other denotions maybe like this, but usually we'll use this because for me personally, it's a bit more easier to understand. But anyway, so to solve that, basically what we have is that it's a fraction, and on top, it will be 7 times 6 times 5 times 4 times 3. Because there are 5 numbers. So 7, 6, 5, 4 is 3, 5 numbers. So similarly, if this number was 4 instead, then it would just be 7, 6, 5, 4. So 4 numbers. And on the bottom, it will just be 5 factorial, which is 5 times 4 times 3 times 2 times 1. And for this answer, we can get that the answer will be 21. So there are 21 ways to pick 5 out of 7 things. And that is the combination formula, which is a little bit more important. And now we can move on to our preview questions. Let me send the first one. Okay, time's up. I'm gonna end the answers. So congratulations, everyone who participated were able to get it correct. Would anyone like to explain how they solved the problem? Okay.
So I use combination in this problem. So there are in total 4 per people, and choose 3, which is 4 choose 3, which we get 4.
Okay, perfect. Thank you. So this is the way that we solve this problem, but since this is like only we can choose 3 out of 4, then a simpler method, we can just choose a person that did not participate. So the way that we can choose 1 out of 4 is also going to be 4. So another property of combination formulas is that, let's say we have C5 out of 2, then it will be the same as C5 out of 3. Because 2 plus 3 is equal to 5, and that will apply to all of the all other combinations as well, except for 0, because they will have 0 way to choose 0 out of each. Anyway, moving on to our second preview question. Let's go.
Even color pick.
Let's get the answers in, and there. So the answer is going to be D, 30. Would anyone like to explain their solution? Yes.
So basically you have 6 windows to choose for when Georgie first goes in, but when he goes out, he's already chosen one, so it's 5. So 5 times 6 is 30.
Okay, thank you. So since there are 6 windows, and if you already chose one to enter the house from, there are 5 left to choose from to leave. So the answer is going to be 6 times 5 equals 30. And now let's do our last one. Let's see. Okay, enter it in. And congratulations to those who got it correct. The answer is going to be C, 15. So for this problem, is that it asks us how many integers between 2020 and 2400 have 4 distinct digits, 4 different digits arranged in an increasing order. So firstly, we know that the first digit has to be 2 because it's between those two numbers, and the second has to be 3 because the second digit has to be larger than the first one. Then therefore the third digit must be at least 4, so it can be 4 or larger. So if it is 4, let's say the third digit is 4, then there are going to be 5 choices for the last digit, which is 5, 6, 7, 8, 9. So then we have 5 choices. Let's see, wait, let me change it. If the third digit is 4, then there's going to be 1 choice for this digit and 5 choices for this one. And similarly, if the third digit is 5, then if the third digit is 5, then there are going to be 4 choices for the last digit, which is 6, 7, 8, 9. So 4. And if we just like list on, then we have 6. The third digit can be 6, 8, 6, 7, or 8. And that would mean there are 3 choices, 2 choices, and 1 choice. And it can't be 9, because if it's 9, then there would be no possible digit for the last for the unit digits. So therefore we have 5 plus 4 plus 3 plus 2 plus 1 equals 15 integers. Are there any questions? If not, then let's move on to our content for our class. So today we're going to be talking about counting principles, and we have 5 concepts that we're going to cover. So the first one is more of a simple method called tree diagram or enumeration, which is called meiju in Chinese. So when counting the number of paths or way to finish a work that the question asks us to, you can try to draw out the diagram to simplify the process. But this is only for like easier problems, because for more complicated ones, it's going to take up too much time. So let's look at an example. Let's see, wait. So it says that, as shown below, a frog jumps among 5 lotus leaves. Let's see. So each time it jumps from one lotus leaf to another lotus leaf, adjacent lotus leaf. And if the frog is on the one marked with A at the beginning and it jumps 4 times, and how many jumping paths are there? So it starts from A, so let's say that it's A here. So we see that the only lotus leaf that the frog can jump to from A is B, so the next will have to be B. So this is a tree diagram. So basically, it can only jump to B next. So this is our first jump. And the next, B can go to A, D, or C. So let's spread that out. Then there are 3 choices from B, which is A, B, A, D, and C. And from then on, this is our second jump. Then our third jump will be that A can only go back to B, so we're going to do B again. And D can go to B, E, or C. So D will have 3 choices, which is B, E, or C. And C will only have 1 choice, which is B, because C can only go back to B. And then B will also be able to go to, again, ADC and ADC. This again is ADC. Wait, sorry. So D cannot jump to C. So D can only jump to B or E. And for E can only jump back to D. So therefore, let's look at the outcomes of here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore, there are going to be 10 jumping paths at the end. Are there any questions? If not, then let's move on to our practice problem. Let's see here. Okay. You answered the question?
So were you just doing the question because your mic was off? Were you saying anything?
Wait, what?
It was like, were you just doing the practice one because I don't think I could hear anything?
Oh wait, yeah. I just wrote it out, but I didn't say anything.
Okay.
Okay, I'll collect it. So as I thought, a lot of people were able to get it correct. The answer is 5. Would anyone like to explain how they solved the problem? Okay.
So, A to B, and then B could jump to A or C, and then from that A you could go to B, and that C you can go to B or D, and then B is for A and C, and D is C, yeah, and
Okay.
yeah, and you count the results.
Okay. Thank you. So therefore our answer is 5. So if there are no questions for this concept, then let's move on to the next one. So the next one is addition principle, also called the labeling method, which is going to look something like this. But let's first try and do our warm-up. Let me isolate it. So basically firstly I'll need to explain the addition principle. So basically what the addition principle means is that for any it's when solving problems about counting the number of ways to go from one point to another, which is the labeling method, is going to be shown and visualized in a grid. So in fact, if we denote, let's say, AI or J as a number of ways to reach a point at the ith row and jth column, say something like this, ith row and jth column, it's gonna be like I and j. this is going to be 0 and 0. Then then the aij is equal to the sum of the number of ways to reach its predecessor. But if a point has no predecessors, namely it cannot be reached at all, then we denote the number of ways to reach it as 0. So we can't reach this the point that we already started from, so that's going to be marked as 0. And something for these, it will be all marked as 1 because there is one way to get to it from the shortest distance. So it will look something like this. Then I'll explain more when we actually get to the problem. So let's first start with our warm-up question. So this question asks us how many different shortest, which means he cannot go back, routes are there in total for Justin to go from his home to the triangle. So to make it clearer, this is his home, and there are 3 ways to get to this square, 2 ways to get to this square, 3 ways to get to this one, and 1 way to get to this one. So we can mark these as 3, 2, 3, and 1, because that's the number of ways that he can use to get to that point. And then for this one, we can see that 3 plus 2 equals 5. So there are 5 ways for him to get to this circle, and 3 plus 1 is 4, so there are 4 ways for him to get to this one, and the destination will be 5 plus 4 equals 9. So the answer is going to be 9. And basically the grid method is just using the same method except you use the grid that looks like this. Let me try to show it out. So our exploration problem is that Simon is going to visit his grandma in a nursing home using a figure that looks like this. So there's a city center, then a nursing home, and he will start from school. It asks how many different shortest routes are there from the school to the city center to the nursing home. So firstly, let's just take it out. This means that Simon needs to go to the city center first, then go to the nursing home. So we need to figure out how many ways there are for him to get to the city center first from school. So using the scalar method, just say we have 1, 1, 1, and 1, because these are the number of ways that he can get to this exact point. Then for this one, it's just going to be 1 plus 1 equals 2. For this point, it will be 2 plus 1 equals 3. For this point, 3 plus 1 equals 4. And for this point, it will be 1 plus 2 equals 3, and so on. So there are 10 ways for him to get to the city center. Are there any questions? If not, then let's continue the problem. So it says that if there are 10 ways for him to reach this point, then there are also 10 ways for him to reach these points. Because from this point on, there's going to be 1 way to go to these points. And using the same method that we used before, then we can add that this will be 20, 30, 30, and adding it up together, there will be 60 ways to finally get to his nursing home destination. Any questions? If not, then let's move on. So secondly, it asks us how many ways, different shortest routes are there from the school to the nursing home without passing through the city center. So therefore, we need to have him to not get to the city center. So basically, the easiest method is to find out how many ways are there in total to get to the nursing home and then subtract 60 from it. So let's see and use the method that we used before. 1, 1, 1, 1, 1. Right here. And using the method, it will be 2, 3, 4, 5, 6, 3, 6, 10, 15, and 21. Then 4, 10, 20, 35, and 56. Then 5, 15, 35, 70, and 126. So therefore there are 126 total ways, and subtracting the number of ways that he can get you to nursing home by passing through the study center will be 126 minus 60 equals 66. Any questions? Yes? Is there a question?
Sorry, I forgot to turn my microphone on. Wait, why did you minus 60? Because my Wi-Fi wasn't that good, so I didn't hear it.
Oh, it said that. So the question is asking us how many different shortest routes are there to like without passing through the study center, and then the problem that we just did is that how many ways are there to the study by passing through the study center. So there are 126 ways in total. So and we want to know how many ways there are that doesn't pass through the study center. So we know that there are 60 ways if he does pass through the study center. So it will be the total number minus 60 equals 66.
Okay, thank you.
Okay, no problem. Now let's move on to yes.
So, we minus 60, I would just want to double check, is because there are 60 ways to go to the city center?
Oh no, because there
Or
are
like past the city center?
yeah, so there are 60 ways for him to get to the nursing home while also passing through the city center.
How can we get the 60 from like the data?
Oh, so like basically it is basically the solution that I explained in the first question. So as you can see, there are 10 ways to get to the study center. So therefore, there are going to be 10 ways for him to get to these points as well. And using the addition principle that we just learned, but you can add these together to get 20, add these together to get 30, add these together to get 30. So in total, there will be 30 plus 30 equals 60 ways for him to get to the nursing home by passing through the study center. And if he doesn't pass through the study center, then it will be the total number, which is 126 minus 60 equals 66. Any questions?
So if the question only gives us the second small question, then we need to draw 2 graphs in total. Is that right?
Yeah, I feel like that will be like a more easier way. Because if you try to avoid the study center completely, then it will be a little more complicated. But actually, there is a way to use this without drawing the first diagram. So you can just mark the study center as 0. Because you're not gonna pass through it. So there are 0 ways for you to get to the study center, and you can just like add it up. Use the same method.
Okay, thank you.
Okay, no problem. Now let's move on to our next one. So this one's a little bit harder, but I'll isolate it. It's actually the last problem on the AMC 8 for this year. And basically what it says is that there's a girl called Michaela who finds all the possible ways to draw a path in a 5x5 diamond-shaped grid. Each path starts at the bottom of the grid and end at the top, and it will only move 1 unit northeast or northwest. To compute the area of the region between each path and the right side of the grid, 2 examples are shown in the figures below. What is the sum of the area determined by all possible paths? So basically, as you can see, both of these have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total steps. And 5 of these are going northeast and 5 of these go northwest. So therefore, in order to find out like how many of those steps are going northeast, so let's find so basically we need to use the combination method, because we want to choose the 5 steps that will either go northeast or go northwest. So 5 out of 10, then using that we would have 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2 times 1. And therefore we will get, let's replace this with 4, and that will be 252. So there are 252 routes in total. And we need to find out the sum of the area determined by all possible paths. So as we can see before, let's use this as an example. Let me screenshot it. So if we have this, and let's see, can I turn it around? And I turn it around, then we can see a different path that goes like this. And if it goes like this, then the area that it covers will be this. So this is also going to be one of the possible paths we have. And as you can see, these two figures fit together perfectly to form the 5x5 diamond-shaped grid. And for this one, it's going to be the same. So therefore, there are going to be pairs within these 252 routes that end up isolated in two areas that come together to completely and perfectly fit a 5x5 diamond-shaped grid. And in order to find out the number of pairs, it will be 252 divided by 2 equals 126. So there are 126 pairs of routes that form areas that can click together to make this diamond-shaped grid. And since each of these pairs will add up to make a 5x5 grid, then each of these pairs is going to make an area of 25. And therefore, our answer is going to be 126 pairs times the area of 25 equals 3,150. So that would, yes? The question?
So I still don't really get what like the C510 is about.
Ooh, which one?
Like start of the question, like the combination bit.
Oh, so basically, as you can see, there are, for each of those routes, there are 10 steps in total. And there are going to be 5 steps that go northeast and 5 steps that go northwest, because it needs to end up at the top and start from the bottom. So therefore, we need to choose the steps that go northeast and choose the steps that go northwest. So that would be choosing 5 out of 10. And we get 252, which is the total number of routes possible for you to get from the bottom to the top.
Okay, thank you.
Okay, no problem. So therefore, our answer it will be 3,150. Is there any questions for the other steps? If not, then let's try out a practice. Okay. answers in. So the answer is going to be D, 24. I'll explain this question real quickly. So as you can see, it says that a path only moves from one letter to an adjacent letter. So we're going to start from A. As we can see, we want to form AMC 8. So there are 4 M's that around A. So there are 4 ways for A to start. As we can see, the path is like symmetric all over from all of the ways, so we can just use one AMC 8 as an example. So since there are 4 ways for A to reach M, and we can see that there are 3 C's around each M. So there are going to be 3 ways for an M to get to a C. So that would be 3. And lastly, we can see that there are 2 8s around each C's. So there are going to be 2 ways for AMC to connect to 8. So that's going to be 2. And therefore, our answer is going to be 4 times 3 times 2 equals 24. So, any questions? If not, then let's move on. So we're going to skip the third and fourth concept and move on to the last one first. Let's see. Will be about multiplication principles. So in my opinion, this is a little bit less complex than additional principle, so these usually apply to problems that ask us how many steps we need to complete a task. So let's say there are a certain number of methods for us to complete the first step. Then let's say there are M1, then M2 different methods to complete the second step, and so on. Then there will be M1 times M2 times all the way to whatever step you need, different methods to complete the entire task. So let's try with a warm-up question. So I'm going to isolate this. It says that Ali, Bonnie, Carlo, and Diana are going to drive together to a nearby theme park. So A, B, C, and D. And the car they are using has 4 seats, 1 driver's seat, 1 front passenger seat, and 2 back passenger seats. Bonnie and Carlo are the only ones who know how to drive the car. How many positive seating arrangements are there? So since Bonnie and Carlo are the only ones who know how to drive the car, and they are the only ones that can sit in the driver's seat. So any of the 3 remaining people can go to the front passenger seat. So let's say this is the driver's seat. This is the front passenger, and these are just like passenger seats. But those don't really matter because you don't need to drive anyway. So therefore, there are 2 people who can sit in the driver's seat, and the 3 remaining people can sit in the front passenger seat, and there are going to be 2 remaining people that can sit in one of the passenger seats and only 1 that can sit in the last one. So therefore, the answer is going to be 2 times 3 times 2 times 1 equals 12. And our answer for the warm-up will be 12. Any questions? If not, then let's move on to our exploration. So, let's see. Consider the digits 0, 1, 2, 3, 4, and 5. How many 3-digit numbers can you form without repeating digits? So there are 1, 2, and 3. So we know that 0 cannot be in the first place. So there are going to be 1, 2, 3, and 5. 5 choices for the first digit. And then in the second place, 0 can be in this one. So there are going to be let's say that we have 5 as the 100th digit. Then the 10th digit can either be 0, 1, 2, 3, or 4. So there are going to be 5 choices for the second one. And the last one, there will be 4 remaining numbers left. So the answer will be 5 times 5 times 4 equals 100. And for the second one, it asks us the same question, except that repeating digits are allowed. So again, 0 will not be allowed in the first one. But then for the second digit, there are going to be 6 options available because 0 can be there, and it will be the same for the third one. So therefore, 5 times 6 times 6 equals 180. Any questions so far? If not, then the third one is a little bit more complicated. It asks us how many 4-digit numbers we can create that are greater than 3,000 but less than 5,421 without repeating digits. So the 1,000 digit can only be 3, 4, or 5. But since there's only a limit after 5,000, we can try numbers that are between 3,000 and 4,999 first. So the first digit can either be 3 or 4. So there are going to be two choices for this one. And we just need to ensure that the remaining digits don't repeat. So since 3 or 4 are already available, then the next one, there are going to be 5 choices, then 4 and 3. So therefore, our answer is going to be 120 for, like, let's see, 1,000 digits. 3 or 4. However, if the 1,000 digits is 5, then we'll have different conditions to consider. So first one, it will be the 1, which is 5. There's only one choice for the first digit. Then we have this 100 digit can be 0, 1, 2, or 3. Let's say 0, 1, 2, or 3. Then there are 4 choices. And we can just, like, for the rest, there are no requirement. So for the rest, we just have to ensure they don't repeat. It's going to be 4 times 3 again, equals 48. However, if the 100 digit is not 0, 2, 3, but instead 4, then let's see, 1 times 1, which is 5 and 4, then the 10th digit can only be 0 or 1 because it has to be less than 5,421. So that will be 0 or 1, and that will be 2. And the last digit will be anything. So in order to ensure that they don't repeat, there are going to be 3 choices for the last one, and that will be 6. And lastly, as you can see, the last choice is 5,420. So there's going to be one additional choice plus 5,420, which is one choice. And by adding all of these together, the answer is 168 plus 7 equals 175. So therefore, the last question to answer is going to be 175. Are there any questions? If not, then let's move on to our next one. So this one asks us how many whole numbers are there between 1 and 3,000 that did not contain the digit 3. So for this one, we can try our 1-digit number, 2-digit number, 3-digit, and 4-digit numbers. So for 1 digit, there are 8, as we know. And for 2-digit numbers, so the first choice, there will be 8 digits in choice, and the next one is going to be 9, because the first digit cannot be 0 or 3, so there are 8 digits left. And for the next one, it simply just cannot be 3, so that would be 72. And for 3 digits, using the same logic, it can be 8 times 9 or times 9, which is going to be 648. And lastly, for 4-digit numbers, it has to be less than 3,000. So there are only 2 choices for the first digit, which is either 1 or 2. And for the next rest, we don't really care. It doesn't really matter because there are no limits. So it's going to be 9 times 9 times 9. And the answer is 1,458. So in total, how many whole numbers are there? It's going to be 8 plus 72. Wait, sorry. 8 plus 72 plus 648 plus 1,458 equal 2,186. And that is our final answer. Any questions? Okay. Then before we move on to the practice problems, let's take a 5-minute break. Done. Okay, guys. Oh, okay. Let's come back. So if you're there, please like raise your hand on the app so I can see you. Hi. Anyway, so let's get into our practice problems now. You can first just do the first one. Let's see. Okay. Okay, let's get the answers in. So congratulations to everyone who participated. Got it correct. The answer is 4,536. So the question asks us how many integers between 1,000 and 9,999 have 4 distinct integers, but basically that is just all 4-digit integers. So it's basically asking us how many 4-digit integers have distinct digits. So as we can start, there are 10 digits in total that can be possible for digit 1, except for 0, so there are 9 choices. And for the second one, since 0 is now available, it will be 10 minus 1, because there was already 1 digit occupied for the first, which is 1,000 digit. That would be 9 times 9, and then there will be 8 remaining digits, and lastly 7 remaining digits. So the answer will be 9 times 9 times 8 times 7 equals 4,536. Pretty simple. And now let's move on to our next one. Cool. Get the answers in. The answer is D, 726. So as I already explained in the exploration problem, basically what we need to do is to find the 1-digit, 2-digit, and 3-digit number that did not contain the digit 1. So for 1 digit, there are 9 numbers in total, and we just have to minus 1, which is 8. And for 2 digits, the first digit can be any digit except for 1 and 0, so there are 8 choices. And for the second one, it can be any digit except for 1, so there are 9 choices. So there are 72 choices for 2-digit numbers. And for 3 digits, it's basically the same logic, except there is a third digit which also has 9 options. So it will be 8 times 9 times 9 equals 648. And by adding it all up together, we get 728. And that will be our answer. Are there any questions? Not, then let's go back to our third concept. So the third concept is a little bit complicated. It's called construction labeling method. So even if there are no actual grids in a question, the labeling method can still be used with creativity. So the key is to notice the directions that we can go, which in a particular question might be phrased as an operation. So for example, there could be 2 teams competing against each other, and a direction can be winning or losing. And I'm going to explain one of them in the exploration problem. So the total number of steps taken in each process is still the same. So for example, if let's say a game is won to teammate with the final score of 4-2, then all of the sequence of reaching this result should have 6 games. But I'll explain that a little bit more later. So now let's move on to our exploration problem, such as an example. So Bugs Bunny is hopping up and down a set of stairs one step at a time. In how many ways can Bugs start on the ground and make a sequence of 6 hops and then back on the ground? For example, one sequence of hop is up, up, down, down, up, down. So since we're going to end up back on the ground anyway, it's just going to be, we need to go up 3 times and down 3 times. So, and the quantity of downward movement at any given moment is less than or equal to the quantity of upward movement. So, let's say we have this grid. Since we're going up 3 times and down 3 times, then the grid is going to look something like this. This is up, this is down, down, and this is up. We start with 1. There are 1 ways for each, and for this one, it's going to be 1 as well, using the addition principle. And adding up together, this will be 2, 3, and 2. 5, and our final answer is that there are going to be 5 ways for Bugs to start on the ground and make a sequence of 6 hops. So the answer is going to be 5. And moving on to our next question, which will symbolize the thing that I just explained now. In the NBA Finals, it was the Los Angeles Lakers versus the Detroit Pistons. If the game was played under the bet of 7 sets, for each victory, the Lakers would gain 1 point. In the end, the Lakers emerged victorious with a score of 4-2. Throughout the entire game, they never fell behind in their points. So how many total outcomes were there for the game result? So we need to draw something similar to what I just did now. So something like this. Let's say that the the ones on the bottom, represent the scores of the Lakers. So the horizontal segment, and the vertical line segment will represent horizontal equals Lakers, and vertical lines represent the points scored by the Pistons. So it will look so the Lakers have scored 0 and 1, 2, 3, and 4. Then the Pistons will score 1 and 2. And so basically, since the Lakers scored first and their score must not be lower than that of the Pistons, and the Lakers cannot have a lead of 4 points over the Pistons, we can end up with something like this. Let me first see if I can rotate this. Never mind. Okay. So it will look something like this. And we can start like this. So for the Lakers, they score, let's say we have 1 point here and 1 way to get here. Then there are going to be 2 ways for them to get to the first point when the Pistons have 1 point. And for here, it's going to be the same way. So let's use the addition principle to get to 5. But since we know that the Lakers cannot have a lead of 4 points over the Pistons, it's going to be empty here. Because then if they get to 5 points here, then that would mean it ends up being 4-1 instead of 4-2. So therefore, we're just going to skip directly here, and the answer is that there are going to be 5 possible outcomes. And that is it for this concept. Move on to our practice problem. The practice problem is going to be a little easier to visualize, and let's start. Okay, I'm gonna connect the answers. Let's see. So the answer is going to be E, 18. So it's a little bit complicated to visualize since there are so much. So it says that Samantha lives 2 blocks west and 1 block south of the southwest corner of her city park. And her school is 2 blocks east and 2 blocks north of the northeast corner of city park. So on school days, she bikes onto to the southwest corner of the city park and takes the diagonal path through it, and then bikes onto to school. If her route is as short as possible, then how many different routes can she take? So basically what I did here was that I drew a huge array and located a random city park in the middle, and then located the home and the school as shown in the as shown in the problem. So here is what it looks like. As you can see, there are using the addition principle and the labeling method, there are 3 ways for her to get you home to the corner of the city park, and 6 ways for her to get you from the other corner of the city park to school. So there are 3 and 6, and in the end, it's going to be 3 times 6 equals 18 routes that she can take. And the answer is going to be 18. Any questions? If not, let's move on to our last concept of today, which is the playing catch method. Let's see. So these usually apply to questions that look like this. So let's say 4 people are practicing passing the ball while wearing red, yellow, green, and blue jerseys respectively, and each person can pass the ball to any one of the other 3 people. So let's say we have red, yellow, green, and blue. So the red person starts the game by throwing the ball, and it counts as the first pass. After 5 passes, the ball still ends up in the red person's hand. How many different possibilities are there for the entire passing process? So we can use something that is similar to a tree diagram. So as you can see here, I've listed red, yellow, green, and blue. And what does it look? So the grid is going to look something like this. So this is the amount of passes. So when there are 0 passes, red has the ball. So we're gonna mark it like this to show that red has had the ball once and the others had never had the ball before. So if they show that they are 0. So the first pass is that means that the other 3 people all have 1 chance of getting the ball because red has to pass it on to them. And therefore now, red does not have the ball. So it's going to be 0. Because there's like 0 possibility that the red person still has the ball. And now, so the other 3 people can totally pass it on to red. So therefore, now red has 1 plus 1 plus 1 equals 3. And for the other 2 people, and for the other 3 people, because there are only like 0 and 1 and 1, that is not them, it will be 1 plus 1 for each of those people, and we have 2. So it's gonna look something like this. Then I'm gonna mark it with a different color. So these have all passed to red, so that's going to be 3. And for yellow, it will be like something like this. So it will end up being 2, and it's the same for green and blue. And using this method and going on, we can see that 2 plus 2 plus 2 equals 6. Then 3 plus 2 plus 2 equals 7 for these. And going on, we get something like this. And for the last step, it will be 20 plus 20 plus 20 for red equals 60. And for the others, they're all going to be 61. But after 5 passes, the ball still ends up in the red person's hand. So this is the one that we're going to look out for. So therefore, there are 60 possibilities for the entire passing process. and the answer will be 60. You guys understand the method? If yes, then let's move on to our next problem. So there is a 5-digit number, each digit being one of 1, 2, 3, 4, or 5, and the difference between the adjacent digits is 1. How many such 5-digit numbers are there, and digits can be repeated? So using the method that we used before, we will need to create a graph that looks like this. So the digits are going to be 1, 2, 3, 4, and 5. And we can personify this as they're passing between each other. And remember, let's say, this is the unit, 10, 100, 1,000, and 10,000. 10,000. Okay. So now we know that they all have equal possibility of being the unit digits, and then 10, it will look something like this. Because we pass them around, and it says that the difference between adjacent digits had to be 1. Then next, it says the 100 digits. So for the 100 digits, the 1 can only be next to 2. So that would be 2. That's because 1 and 5 can only be next to one number to be able to satisfy the condition that the difference between adjacent digits is 1. However, 2, 3, and 4, because those 3 numbers are in the middle, they have 2 numbers next to them 2 adjacent digits next to them that have a different 1. So therefore, they have more options to choose from. And now, using the method, it will look something like this. And lastly, add them together. We have 3, 6, 6, 6, and 3, like this. Adding these together. So these are the things that are getting added up together. And lastly, we would have 3 plus 6 equals 9 for this. 6 plus 6 equals 12. 6 plus 3 equals 9. And then now we only have 6 and 6. So therefore, in the end, we are going to have 6 plus 9 plus 12 plus 9 plus 6. And that will end up with us having the answer of 42. Are there any questions? If not, then let's do our practice problem. So let's get our answers in. The answer is E, 7 out of 27. So there are two methods, and the first method is the one that we just used. So as you can see, it's basically the same as passing the ball. A, B, C, D are the ones that I've labeled the leaves. So when there are 0 steps, A is as 1, and B and C and D are all at 0. Then for the first step, A is going to be 0 since he has to leave the leaf, and B and C and D all have one chance of getting jumped on. And using the arrow method, then A is going to be 1 plus 1 plus 1 for the second step, and B and C and D are all going to be 1 plus 1 plus 0. And going on, that will end up us with 3, 2, 2, 2, 6, 7, 7, 7, and the final step will end up with A having 21 possible outcomes. And total, there are 3 times 3 times 3 times 3 equals 81 steps or probability for outcomes at the end, because there are 4 leaves, and for each one there are 3 steps for the cricket to jump on it. So therefore the answer is going to be 21 out of 81, which is also 7 out of 27. And our second method, and there's actually a second method that is similar. So since we see that the first jump cannot be from A to A, and the third jump cannot be for the cricket to jump on A, because if the cricket jumps on A for the third jump, then it cannot jump. It has to jump onto another step for the last jump. So for this method, we're just going to label this as A, and the others all as B. B just represents a random leaf that is not the one that the cricket started from. So there are going to be 2 ways. One is that both the second step and the last step is 2A, because we know that the first and third step cannot be 2A. So it's going to be the root is going to look something like this. And since we know that A definitely has to jump to B, then the probability of A jumping to B is going to be 1. However, the probability of B jumping to A is going to be 1/3, because there are 3 other leaves that B can choose from, and 2 of them are also B, and only 1 of them is A. So it's going to look like this. And again, A has to jump back to B, so it will be 1 again. And lastly, this will also be 1 out of 3, and the answer is going to be 1 out of 9 for the first way. And the second way is that A did not return to A for the entire process. Then we will have something that looks like this. So again, the probability of A jumping to B is 1, and the probability of B jumping to B is 2 out of 3, because there are 3 leaves that it can jump to, and only 2 of them are B. So it will be 2 out of 3, then 2 out of 3 again. And lastly, B goes back to A as we said before. The probability will be 1 out of 3, and we will end up with 4 out of 27. And our final answer will just be adding 1/9 with 4 out of 27. And our answer will be 3 out of 27 plus 4 out of 27 equals 7 out of 27. So therefore, the answer is going to be E. Any questions? If not, then that's going to be all for our accounting principles class. And I'll post the homework right after class, so I'll see you next Saturday. Bye.